Wow, Neil Armstrong. Hey, wait a minute. For whims. Productions.
Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
Don't see the curvature of the earth. That stuff is what?
GLOBEBUSTERs taking over. Bye-bye, Moonlight and Rover. NASA so mediocre. Sorry, but your ball is dead. But your ball is GLOBEBUSTErs taking over. Gotta ride this roller coaster, but the truth is getting closer. Sorry, but your ball is dead. But your ball is. Get the shovel for the spice of a piecing up the puzzle. Need a burst of bubble. Evil gonna crumble, yeah? Sit down, be humble. Got the body by the fumble. You'll get mad because I just fight about your uncle.
And then they call me the liar. I mean, it's absolutely unbelievable the pathetic techniques that they have to use to prove their heliocentric model.
Props at the president, Jaren got the evidence. Arrows laying desert wisdoms, I shark them is evident. That the earth electric and it's residential residence. It's heavens and I hope you settle in like some sediment. If we so wrong, why they lying to discredit it? That's not too intelligent, that's a guy not a in court. But we ain't really in the settlement. It's time to awaken from the pseudoscience sedatives.
GLOBEBUSTErs taking over. Bye-bye, Moonlight and Rover. NASA so mediocre. Sorry, but your ball is dead. But your ball is GLOBEBUSTErs taking over. Gotta ride this roller coaster, but the truth is getting closer. Sorry, but your ball is dead. But your ball is.
Inner World Productions.
We accept the reality of the world with which we're presented. It's as simple as that.
Hello, everybody, and welcome to another edition of GLOBEBUSTERS Tech. I'm your host, Zach, Good Times for All, and today we're going to be going over modeling a mystery. This is revisiting some of Cami's old work from back in the day and kind of how far we've come and the puzzle pieces we found along the way. That's one of the hardest things is trying to put together a puzzle when you don't know what it looks like. Kind of reverse engineering the data you can collect and trying to put that into a cohesive, coherent model that actually would function like this place does. Thousands of brain hours, just thousands upon thousands probably, have gone into this thought, just by the people on this panel, let alone all the thousands of all the people out there. And there's a lot of different ideas on how this all works and what's out there and what's above us. But I always, until I know something, I don't know it. And yeah, I will honestly say I don't know what's out or up. I do believe that it's contained in some sort of way, gas pressure and all that kind of stuff. But what's actually up there containing it and how far it goes and things like that are questions I don't have a definitive answer to. I don't think any of us really do, at least here on the panel. So yeah, we're going to be looking into ideas and possibilities of what this place, might actually be. But before we do that, we're going to say hello to the panel. We're going to start off by saying hello to Miss Karen B. Karen, how are we doing this week?
I'm doing great. Happy to be here. Happy
Wow.
Thursday.
Happy Thursday.
Happy Thursday.
As Benjamin would say. Hail Benjamin. Awesome sauce. Kyle Adams from the Kyle Adams channel. Kyle, how you doing this week?
Doing really well. Yeah, just been debating a lot of people lately, really stubborn people, the globe earthers. It's amazing how stubborn they can be sometimes. But it's been really fun because I've been going over a lot of like the old GLOBEBUSTERS content and really just pulling out the magnifying glass on everything we've said about the whole electrostatic gravity. And I've been talking with you a little bit about that off air. But yeah, it's been really fun just to see where these claims are coming from and going through the documents and listening to all the lectures, you know, really pulling out the magnifying glass and doing my homework on that. And yeah, the whole 100 volts per meter claim, like a lot of the globe earthers, when they first hear that, "Oh, whatever, you're smoking crack or something like that," and they'll be so like incredulous about it that they just instantly dismiss it. And then you pull out the document and say, hey, look, this claim actually comes from Caltech. Do you still disagree with Caltech here? Oh, wait, nope. I agree with you now. I agree with you. And it's just so funny, the whole appeal to authority and how it works. It's just
well, it goes to show how little they know about their own model and how it actually works too, right? That's one of the greatest things about it. You brought up the electrostatics. Yeah, if you even look at their equations, it says electrostatics is what's holding things to Earth, not gravity. Gravity is orbits, has to do with things orbiting another body. It has nothing to do with something clinging to another body. That's all electrostatics. That's what the math says even. Yeah. And people still want to argue. It's crazy.
Yeah. And then when it comes to the Walter Lewin lectures, I get globe earthers are like, you know, he's a globe earther, right? Why you listen to him? You know, like, why do you accept part of his whole claim, but you don't accept the whole thing? What's up with that? I'm like, well, we're not really prone to throwing the baby out with the bathwater. That's what I like to say on that is, we're not, it's not all about the person saying it, it's about the quality of what they're saying. And yeah. And so, yeah, we're not all about the appeal to authority on that matter. You know, it's not, that's
that
not how
person
it works.
has a lab coat, they must be right.
Yeah.
Yeah.
And so we make a lot of appeals to authority to other people because we see how they work. Because if an authoritative figure says it, they instantly agree with it. And so it's like, okay, well, that makes it a lot easier for us. But yeah. And so it works really well with talking to the globe earthers. But yeah, when it comes to talking to other flat earthers, that's where we have to really go through with the fine tooth comb, right?
Well, yeah, and that's when testing things is so important, which comes up to a topic we're going to be talking about tonight. A lot of this stuff that came out of Cami's brain was because of, actual physics. It wasn't just hey, I have an idea and, let's just throw it out there and see. No, you're not going to see a lot of that here. A lot of our stuff, we have an idea, but then we go research. And then beyond that, we test it to see if it actually works. That's why I went out and got the Van de Graaff and all these other toys to play with, because I saw a professor doing it on YouTube and I was like, well, I've seen illusionists do all kinds of things too. I want to see if this actually works like he says it does. And then now I know. Now I'll share this with people adamantly and say, no, this does work. I've done it. Here's the videos to prove it. I've done it. Yeah. So, well, before we get into the end here, our last panel member, last but never least, Mrs. Cami No Doubt. Cami, how are you doing?
Oh, I am on mute because it's such a rookie mistake. I'm doing good. It's been a interesting week. I love hearing my husband's voice, Bob's voice on the intros. It's so special.
Sorry, Cami.
Am I low?
You're all over the place. Maybe turn it down and scoot forward. But yeah, leaning back like that, it's like cutting out real bad.
Okay, let's see if I can redo things. My son changed some. Is that better?
Yeah, you just got to be closer.
Okay, so we'll try to do that. Wonderful hearing Bob's voice on the intro. Again, I can't say, and touching back on all the old GLOBEBUSTERS work, he inspires me every day still, and his why I keep doing what I'm doing. And this is what we wanted to do. And I hope I tried to be strong and, try to make it happen. Found a lot of
You're still cut,
inspiration.
Cam. I'm sorry
Yeah.
for cutting you off again. You
Yeah.
need to move your mic somewhere else to be
How's
closer to
this?
you.
How's this?
Much better. Much better.
It's
That
really
works better.
close.
Yeah, you got to
It's
stay
either-
close to it though. As soon as you sit back like that,
Okay.
you start
Yeah, the
cutting out
mics
real
like
bad.
it when you go right up to them and talk like
Yeah.
Like this. Hello.
that.
I can do it. Okay, that thing. No, it's been a good week. I watched Ben Balderson played some old weaving spiders, and they had an episode with Crow on it, and going over the second sun and polarity and different things, and get my mind buzzing again, which is talk about photography and filters. And I will answer. I don't know anybody else. I don't know if anybody else has watched the show, but one of the things they were talking about on the show was when we're doing the photography, we're using infrared photography to get the long distance and that. And everybody is asking, well, have you tried ultraviolet filters? Okay, maybe the directions, because we've moved. This is on Zach is here doing my microphone, by the way. We switched rooms, and so I don't think the settings are right. They haven't, you're not going to, how's that? Okay, maybe that's better. Maybe for different applications, it's so weird, like looking here and having this big microphone right there in front of you. But maybe in different applications, it would be appropriate. What ultraviolet would do if you were to put an ultraviolet filter on a camera and filter for it, is you would actually pick up the neon, the xenon, all of the different things in the atmosphere and the haze. In other words, you would, instead of seeing further, you would be able to see the haze more, if that makes sense. You would see everything that fluoresces in the atmosphere and that. So putting an ultraviolet filter, why I'd like to do it for some other things that are with different things and purpose, as far as looking for long distances and clarity and things like that. That's the exact opposite of what you're doing. What you are doing by the infrared is you're cutting that spectrum. So you're cutting all of that stuff that fluoresces and glows and makes it hazy and makes it that you can't see in the distance. And again, the ultraviolet is going to do the exact opposite, make it so you're looking, pretty much through fluid, which you are. So again, maybe it would be a better way of looking at what we're really, looking at that way, but you won't do your distance photographs. One of the things, just brings up different mind thoughts everywhere. One of the things, by looking at modeling a mystery and breaking the globe model that we see too far, that is an optic that we see too far. It cannot be an optical illusion. In other words, we have a physical barrier between it and the way that they're doing. I can do refraction. We've done different things. And this is again where we test it. The way they implied, again, the seeing too far, we do see too far. It doesn't work. You can't get around that. But when you do look at optics and look at different things you're looking at, especially up in the sky, optics, magnetics play with optics. Everything we have in the sky plays with the opticals. They all have an optical effect on it, one way or another. And so it's a little bit different than the ability of seeing too far. They'll sit there and say, well, seeing is believing. If you see this and say that, and that's exactly what you see, then you have to say that when you see the arrow backwards, like through the glass of water, that's reality too, because that's what you see. And again, everything is always discernment, judgment, what you're seeing and how you're applying it. This whole modeling a mystery has been in co-tandem with, busting the globe. We're breaking the globe for the reasons it doesn't work. So I think we should be careful that when we're putting together our model, we're looking through the same type of critical filters as we're putting together our different models. And why we have to, it's again, I'm going to put a lot out there and on model ideas. And I do have a lot of different model ideas, and that, do I know what it is? No. But what I am doing is I'm running it through things that work that would meet the test of reality. And I think that's our best direction to go to, is find different possibilities that actually work with reality. Now, learning the vocabulary and knowing the words and doing fancy stuff on it isn't really doing the work, because again, like I said, I've found several things that work in analog that don't work in digital. And again, the Polaroid filters are one of them, the mirroscope and actually mirroring temperatures and things like that. Things that work in reality that don't work when you program them in. Another way of looking at that is the old paradox in math versus science, where I'm not sure which is math and which is science. Cal, maybe you can tell me and you can maybe remind me of the thing. But the story is if you had a race and a timed race, you could time it and your start and your finish. But I think it's your scientists, is it your mathematician or your scientist that took it out of it, that said no, because no matter what, you can always, from the beginning of the race and the end of the race, you can always cut it in half and cut it in half and cut it in half. And so therefore you could never measure the end of the race, because you could never get to the end of the race, because you could always take that amount and divide it away. Again, this is getting into the realm that I call stupidity. This is where I call what a lot of people do, and the overthinking of concepts. So it's like, again, people step out of like the woo-woo world that we're living in, and that believe in this, and can you wrap your head around that and start testing things. Yes, if you start a race and end it, there is a start time and an end time, no matter how long, how much you can sit there and say it couldn't possibly happen. You can reason anything, and a lot of the things that people are piddling their ass around, like, and discussing things, are again arguments that go, in my mind, nowhere. I'm not going to sit and play in those arguments. I want to go where, and places that we can't go there. Again, I'm fine tuning over. I'm not meshing over. I'm not saying anything, but like, for instance, gravity and electrostatics, I have a perfectly working model that works, that we've tested. We've done the Van de Graaff, we've done all of the tests on. I'm not going to spend years and years arguing with density buoyancy, which is retarded, because that is part of the whole. Of course, there's density and buoyancy. Or arguing that the Earth must be flying up to account for this, when no, it couldn't be flying up to account for that, because no, we do have different areas of microgravity that are around it. If you push something up straight up and doing it, first of all, where would it be going? That's absurd. And second of all, that also is a complete paradox. There's so many things that don't work. So just because you don't understand like every little nuance on it, suggesting something that has more problems, again, we shake it down and we get to our best, and we call it a theory. We say we don't know, but this is our best working theory.
I really like what you said there about the math and getting lost in the math. You're talking about how the people who are way into math will say, oh, there's no end of a race, because you can just keep dividing it. And if you can divide it an infinite amount of times, that race mathematically should be an infinite length. It's just totally preposterous. You can't get lost in the math like that. And I love that point. That's one very much well worth remembering.
And that's also with the math for the people that do like the 8 inches per mile drop, thinking that if you take an 8 inches per mile drop, you can add up however many, that 8 inches, and take it times however many miles there are on the equator, and say that this is how much curve there is. That also is an absurd type of concept. When you're measuring drop, you're measuring on a surface how much it drops, and depending on how far you go out, it's going to go further. But because of the way the number works, it works very much. It works very much as the reverse of the coastline paradox. The coastline paradox is where everybody measured coastlines differently. Well, we'll take that, and depending on how you measured it, did you go into every little inlet and go around it? Depending on how tightly you measured it was how much coastline you had. And so you had people claiming they had more coastline than California by just measuring every little like inlet and things like that. So you'll get into paradoxes on like how much space is there. Well, when you're measuring the 8 inches per mile drop or doing anything like that and taking it around a globe, what happens is if you did how much drop there was per 10 miles, which is that, and then incremented it out, every time you have more drop, you're making a bigger outside circle. You're making a bigger outside circle. If you made it a millimeter or an inch increment and built it all the way around the Earth, then you would show no drop whatsoever, or no drop. Confusing the amount of drop with the amount of curvature are, again, they're just two separate things, and people get caught up and lost in it. So it's just another, you can imagine a string, again, when you make 10 miles out compared to 1 mile out, you're making a bigger frame around your circle. Again, you're doing straight lines around a circle and are just drawing, making a bigger outline around it. It's not measuring anything but that, if that makes sense. Even though there really is that much drop, it's always depending on where you, the observer, is standing, and how far away it is will be that much drop, and you can use your formula. Did I just confuse the hell out of you, Kyle? Or
No, it's just writing that down for later. The whole 2 mile race.
You understand?
I like that one
Yeah.
so much. I'm always thinking, I've got a saying that I repeat a lot, and that is, just because 2 times 2 equals 4 doesn't mean a yardstick is 4 feet long. Is a saying I just continually use all the time, just thinking about the math there. And so,
right, to get the math there,
the 2 mile race thing really, it's right very well with that.
And there's many ways to get to 4, and that's why on these models, what I'll call everything a theory and not really a model, but just a theory, because right now at this point I'm theorizing, but I'm trying to use really good filters for it. So at that point, I think should we start, or anybody else have anything to say or any questions?
No,
Anything in the chat?
All
right. Well, this started again at the beginning, 2014, 2015. And let's see if I can present.
Okay. Are you going to be sharing sound at all?
Very possibly. Did I did it right? I don't have to share sound. No, I don't need to share sound on this one. I can go in and do it. I'm just going to do some concepts on where we started.
Okay, it looks like you're going to share the StreamYard right now.
Right now, okay. Well, I can pull something out in there as far as
you don't want to because then you could give away the StreamYard link at the top, and yeah. I think I have control over it, so it really doesn't matter.
How is it that when I'm pulling things down to the, I should go this way. This is fine.
You want to share the entire screen?
Okay, am I sharing the entire screen? Do you have the Fluorescent going now?
Yes. There you
All
go.
right, then I have the whole screen up. So we'll do this finally and just talk. And so the first thing we were doing was, we did the skies first, but we'll go to the Earth. The first thing we did was like the map. And what I did with the map and people doing it is I'll tell people how I got places in that on the model, and then we'll hit where the model is. On the map, what I did is everybody said that the Earth was a oblate spheroid. So I took a whole bunch of little oranges. They were called adorbs, actually. It was really cute. I thought it was funny. Who's moving the microphone? Does that do better? Okay. So we have the microphone. It's too loud? Oh, okay. Let's see if this is better. I can't tell at all how it sounds, so I'm going to trust you on it. And I'm sorry, I know how important it is to have good sound. Karen, are we okay? Because I'm in here.
Yeah, that sounds good. You sound good right now.
Good. Okay, so we took up I basically bought and peeled, drew continents and carved and did a whole bunch of little oranges, drew continents on it and said what would happen. And we'll do the visual with you that if you do this the way you peel it around the North Pole, if you were going to flatten it and take the orange out of it, first of all, it's really easy. You can like make a cut along the peel on the equator and do 4. If you took the North Pole and fed it in and folded over the pieces, you'd see they would overlap. And if you spread, like even on the line, spread the, so again, if you even took where these lines were, did a peel, let's say you took your peel along here, peeled it, which I did, pulled the fruit out and then laid it flat, what would happen is again, they're not going to lay totally flat. They lay pretty flat, but they're not going to lay pretty flat. And I used an oblate spheroid, and I can't believe how good it got on it. I mean, I used, again, the flattened top. So it overlaps some a little bit. And then, of course, on the bottom, in order to do this, because of the way we see out, if you keep on cutting them and cutting out the edges on them, you pull them out and there's spaces in between. We looked at the lines in that.
Did you get any pictures of that when it was done and pulled out?
I have some. I don't have any up on my screen. Very few, because I didn't, and I probably threw them away because I'd smeared the orange, smeared the Sharpies. I didn't cut well. In other words, I used it for concept. It was a really, really messy spread out, but I had them laying around the house flattened out. But I do have to say, again, once I did the peel and things like that, my Sharpie and the orange juice, it didn't hold. So I did have them. They were really messy. So what I did do is I out pieces, and I took a top and a bottom hemisphere shot and left the top one, the northern hemisphere, in there, but I cut out the southern hemisphere, and instead of again, the way we do it, just attaching it, because where I wound up cutting on the orange, no matter how many times I cut it or peeled, because I couldn't cut through trade routes, I couldn't cut through continents, I couldn't cut through, there was a lot of things I couldn't cut through when looking at it with reality. Where can I make the cuts and not mess with our plane travel, not mess with our underground cables, not mess with, again, where you make a cut through it. And I obviously can't cut directly through a continent. You know that there's not space in the middle of a continent. We would have picked up on it. So I had to work with reality. And the reality told me, like, the ocean here, I'm trying to remember the name of the ocean here. Is it Marshall Island or something? There's an island down here that is, I believe it's owned by the Netherlands. But what's interesting about this island that is down here, Karen, is less people have been to this island than to the moon. And nobody goes there. It's so hard to get to. You're like, well, why doesn't anybody like jump off from South? Do you know when people go to Africa or to Antarctica, they always jump off either here or here? There is no jumping off anywhere else. If you, it's almost all of the people, most of the tourists and stuff go, and they'll even tell you if you're in South Africa that you need to get to Antarctica, or even in Africa, they'll tell you your best ways to go is your best one, even though it's about the same journey, is to do the South America and jump off, because there's a lot more places to see and more touristy things to do. The other places you can fly into Antarctica are Australia and New Zealand. Antarctica is it's got a nice little groove in it. It's called East Antarctica and West Antarctica. And it was on the maps, the old maps before, it was in as two separate continents. And I ran with that and put East Antarctica here and West Antarctica here at the beginning, because this is where people go. And these places here, your ice wall, people don't go.
People don't
They
go
don't-
south of
They don't
South of
go.
Africa. The whole South
They-
African
No.
Antarctic.
No, and they don't
passage
even
is
go to
broken.
the islands that are plotted here that I thought I couldn't cut through islands here, saying there's an island here. I can't mess up with this, but it turned out that my island here that I couldn't mess with the reality of cutting through, it's a volcanic island that they said was made of limestone and too fragile to have people and ships dock on it. It would do too much damage.
I've never heard of a volcanic island made of
Limestone, that boats and that they didn't want people there, because not only is it too hard to get to, but it would do too much damage. So we've just said that nobody can set foot on this island. It's an island that you're not allowed to set foot on. So even though if you go to a map and say, well, yeah, no, there's an island here and there's an island there, this island here, guess what? You can't set foot on it. And
This island is too fragile for you to walk on. What?
yes, and ships to dock. And they said besides, it's hard to get to anyway, and there's nothing in the area. So when you go to Antarctica, you drop off here or you drop off here and here. And so I dropped Antarctica's on the map and did it. And again, this is just your starting point. No matter how many times I peeled those oranges and I went through the whole bag of them, I wanted to get a lotus flower or a flower of life. I mean, I was really thinking of something, special, spiritual. I had the things getting on there. No matter how many times I did it, I got a goddamn turtle. Now,
The turtle's back.
the turtle is back. But what's just funny about that was, again, this is 2016 and 17. Everybody is doing their high-tech simulation theory and everything. And it's like, oh, good. Everybody is making fun of like flat earthers because we have a sitting on the back of a turtle, and yet I'm getting a map that looks unmistakable like a turtle. Just, a fun side note on doing it. Graphics lines would need to bend on this. But again, this was the fun concept. What this does do is it does the all important where people are moving things around. We're keeping things in time. We're keeping every longitude and latitude line is on here and accounted for on there. And you keep, so in other words, by like mapping this way. Now, I believe we have our problem though with the North Pole, that the North Pole, things in the North Pole that catch my attention in the mapping is like Canada is supposedly 1.6 times the size of the United States. Canada is the biggest, and then United States, the second biggest countries on the Americas. And Canada, to me, does not look anywhere near 1.6 times larger. I like some of the older maps, and I don't have a good one here to show at the time. That's crazy. That have where the continents look a little bit bigger on North America instead of so squished like on the WHO map, if that makes sense. I do believe that they are condensing the North still on those ways that we may have to in reality deal with the problem. Like I've, thinking about it, is the center maybe not a perfect circle? Is it ellipse, an egg shape or something, giving us more area to work with and more spread? Or is it, possibly bigger? Things that run through my mind. This I'd like your thoughts on, everybody.
Yeah. When I first started getting into flat Earth, like years and years ago, I started to make this great big map, kind of similar to what you're doing, but I decided to make mine completely off of plane flights. And I had each length of string trying to represent a certain plane flight. And just assuming that all of the planes went at the same speed, and it was kind of a big mess all over the place. And I just kind of threw up my hands. I'm like, you know what? Not all planes go at the same speed. And it was just kind of like, kind of figuring things out. And then I started learning more about the jet streams and about how that's going to throw and be a big pickle into all that too. And then, do a little bit further research. And then it's like, oh, well, you know what? Some of these plane flights might be totally bogus. Just doing the whole Truman Show thing, oh yeah, you can fly from here to here. But then all of a sudden you get a detour and it's never the way it was advertised. Yeah.
So, no, that is one. And I was going to say, Kyle, I didn't do that. I did look at, like, for some of my verifications, rough verifications, I did flights. Like I always pay attention on travel channels, not how long people are in flight, that it does take people in northern Russia. It seemed, long Moscow to Purchase that are 8 hours. I've looked at different distances, and people do seem to be flying large distances on the northern continents, where again I don't see a lot of. Again, I think we're more spread than the land is hidden. We track land too well. I think all of the deceptions are with there, but with your flight strategy, that one I brushed off immediately, because if you go in one direction, I've traveled too much. If you go in one direction, it's so much faster than the other direction. So which direction are you going to take the measurements from? What streams and exactly your jet streams doing it? Because again, your flight times to the same place can be quite a bit different, and especially in different directions.
Yeah, when it comes to map making, another really, really important factor that everyone should be aware of is it is illegal to make a map in China. It is banned. And so, like all of our
Why is
Google
that?
Maps. Sorry, what?
Why is that?
They consider it a matter of national security. And so they literally falsify all of the maps. And you can look this up there. But yeah, all of our maps of China, they are falsified. Google Maps falsified. And so they just kind of warp it here, squish it there, and do all this kinds of stuff. And then when Google Maps openly admits that these things are falsified, you got to wonder, where else are they doing this at? If they're doing it here, why? What makes you think Russia's not doing the same thing?
Yeah,
We
no
know
doubt.
we know that there are deceptions in the maps. We know we've had them a long time, but we also know that we have practical things traveling in that we can detect some reality in it. I think this is one of the best maps I've ever seen. This is off of Beauvais. Just flatten that sucker out, and
So right there in the center of the Atlantic, nothing travels through there, right? Most of
nope.
the flight
Nothing.
travel is all north to north up there. They never really have to go.
Nobody goes down in this area down here. If you see
No,
where my
I'm
cursor
talking in
is,
the North Atlantic between the United States and Africa there. Does anybody go like right in the middle there?
this right here is a short jump off. They jump off here. Yeah, they do. They go. They jump off here and go. This was the whole slave islands and everything. Is all of this right here.
The Bermuda Triangle is right in there.
But no, they sent ships and everything. They definitely shipped and sent to
Oh yeah,
these
Bikini
islands.
Atoll's out there in the middle
Mhm.
too.
Yeah.
Okay.
You've got a whole bunch of stuff. It's hard to, you can change the distances because they do everything they can between the nautical miles and that to change it for us. I love the way that they have Greenland positioned on here. I think that this is accurate. Again, it's just a different way of looking at it, but what you're looking at is you are looking at a $450,000 watch.
Wow.
Unless you want to buy me one.
Crazy expensive watch.
Right. These are people, this is all about in time, being in time on the watch. They also have the moon phases and the sun phases. You can go into the different Beauvais lines. I'm not sure if it's Beauvais or Beauvais. I'm trying to remember. I thought it was Beauvais. It's BOVET.
Yeah, they're really nice. I've watched
And
them
if you look at
put them together.
They're work of arts, and they're all about keeping perfect time, which again, if you know where you are in time, you'll know where you are in space. If you know where you are in space in time, if you work the sky and the earth together, just a fun little thing on it. Then let's see. So on the mapping, we did the layouts, and then we started looking at where do we want to go? Where do you want to go? Do you want to look at an overview of the whole model and ask me questions, or is there a place? Do you want to go to magnetics? Do you want to go to the sky? I'm trying to think of the order I did it because I was going between all of them. I know that we worked the sky. So let's talk about the sky a minute. Let's do.
Yeah, wherever you want to go next.
Giving a layout, and we'll do the model and then again get some different things. Karen B, thank you very much. This Karen put together the graphics for me, else I would never have. She's so wonderful. I also think that the map that she did under here if you wanted an accurate map, I think it's, even though there, I think it, again, just her natural sizing on it is pretty good. She's got a lot of information that she knows just from working on it. She artistically, without doing measurements, she'll say, well, I didn't, this was just casual, but her instinct on it, she's got some of the best sizing on her work. And it's instinctively, I think she's right on this. This one, looking up at the sky, what I took on the map is I took the lunar nodes from mainstream, and I took how they observe the sky in mainstream, not how they work it to the globe model, but how they observe the sky. So when I'm looking at the astronomers and how they observe the sky, they say this, like over here, this is where the moon looks higher than the sun, and this is where the sun looks higher on the nodes. These are like dancing circles going through, but they will also say, in the models, again, where it appears that they're ascending this and that, and this is where they appear higher and lower. I took the appearances and I took their lunar nodes. I just moved their nodes they had at the pinch point, which would work if you were heliocentric in the model. All I did was quarter turn it, so we made our nodes where they would work from looking out from underneath it. Now a quarter
It's like
turn.
an electromagnetic node that's causing the.
Don't. We're not going to. There's too many different words of nodes on there, Kyle.
Yeah.
And so that's not on that one, but we will have a whole show on nodes and the different ways you can use it. We can get into the electromagnetics on that, but it's a whole different than the pattern. We'll get lost.
Notice
and that
such a
type of
weird
thing.
word. Like you see it in plants, you see it in tides, you see it talking about astronomy, talking about the transitions of the moon. You talk about it in electronics and like, yeah.
I promise you a show topic, and we'll call it nodal points, because I am Cami Nodal, and Bob. It can work. We can work with the last name. And my husband and I too, we talked about all of the different nodes, but that's why I'm pulling you away from that, because of the different things we can get. When I'm talking about the nodes here, I am talking, just keep it in the sense I'm talking about, is they're going to talk the nodes, the eclipsing nodes, and that, again, where you would get your eclipses. And in a heliocentric model, if you think about it, where they would pass over, if you were in the middle of the circle, in order for it to do that, that would be this pinch point, right? But if you are underneath the way we are, looking up from a flat Earth model, laying on the ground and looking up and looking at the way we see the skies, your nodal points would be where one is on top of another. It would not be at the pinch. Or maybe, that's how I see it from underneath it. I would see maybe their nodes would stay there. The reason also on the crook, I took from the crook the word cardinal and directions in that. And cardinal, your base word would be to crook it or to turn. And so I turned it, I put a turn in it. Your turn might not be there. You may say it this, but the eclipses make more sense this way. And all of your moon phases make more sense when you crook it like the cardinal rules. If you do this and move your nodes here and look at it from underneath, and we've done the moon phases before, so I don't know, I'll do it over here again, but as the sun rotates around in 24 hours on the yellow, the moon is going slightly slower. So they're doing it in a pair. So if you took these two, the moon's following with it. And as it's following, it's slowly following more and more behind every day. Every minute, every second, actually. It's just traveling a little bit slower. So what happens is from when they're together, new moon, if you were to wait like 3 days, you would see your waxing crescent appear. And that is when your moon has fallen back enough through here. At a week, you're going to see your first quarter, and that's when it is on here on this model, it would be at equal height. With this, again, if you had dancing rings over here, as it grows, as you're getting close to 2 weeks, now you're at 2 weeks, you're at your full moon, it's at its highest. And what I did in the model is I added a little bit of physics to the model. I added quantum locking. And with quantum locking using magnetics, I used quantum locking and temperature, and I used distance to the sun to gauge our temperature, saying that when the moon was closest to the sun, it is at its hottest. As it gets further away and falls back, it gets cooler. So as it cools off, the magnetics are going to get stronger, and that's going to cause it to rise. As it gets further still, this is a point where I get a midpoint where it's in equilibrium with it. It's further away. Now it's on the exact same plane. At this point in time, it's at the same plane. When you're looking at these spinning circles on it, these are at phases. So if you look at the phase of the first quarter, for instance, take it all the way around the circle and the distance. It's as it goes around that day, the whole circle, they're at the same height. At the full moon, the day of the full moon, it is higher than it. Again, the full is higher than it the whole time. The sun, your sun is over here, lower than this model, but again, your full moon is at its very highest. So again, it's taking it and taking them in time in the phases. Can anybody, Karen, I know I'm not explaining how they're going around for people that staying with it. In other words, that pattern is where it is on that day with each phase.
What do you mean? Well, I think you're explaining it fine. You mean where the moon is in relationship to the sun on what phase?
Right. In other words, if you kept the sun here and the moon here, this is on the line. Always keep the moon here. Always keep the sun here. But as you're moving the moon, as it's in that phase, that's its height. So this height is equal. This height gets higher. This height gets higher. Your sun is staying at the same height. When it is a new moon, they are close together. When it is a half moon or your first and last quarter, it is, again, directly in time, halfway between. And again, the way that they rise and set does is perfectly in time. That would be a whole, we talk about how they rise and set in time.
Mm-hmm.
So I used their model of what they see in the sky, added that and added fluorescence in order to get the moon phases. If I made the sun a light source and a polarized light source and a UV light source, which we know it is all of those things, that I didn't have to do anything. If I made the moon fluorescent, which again, will cross things at this phase because we're just looking at the sky. But if I made the moon, if we looked at the moon and even said like different rocks and things in nature fluoresce, if you add the common attribute of fluorescence and had it interacting with the sun, just being round and it rising and falling, it will create the phases of the moon perfectly in time. And I
think people need to realize that these circles that you have there, they rotate, and so you're not only going to have new moons only above Australia, but it's going to
It's just showing where the moon is in relationship to the sun during that phase. So the first quarter moon is 90 degrees out from the sun, and the full moon is 180 degrees. Right, because it's going to be opposite the sky of the sun. So if you see those memes that show the sun next to the moon, the full moon, the setting sun next to the full moon, that is photoshopped. Don't share it. It never happens.
Doesn't work that way. Well, I know somebody says it. Think of it as like, as it's getting closer, it doesn't need to be as charged or as bright, because the sun's there and it's nice and bright. But when the moon gets away from the sun, it gets scared, so it has to get brighter, so it's not in the dark all by itself. You know, something kind of like that. So the further away the moon is, that'll be its brightest part because
Yes.
it doesn't want to be in the dark all by itself. And then as it gets closer, you know, it can get dimmer and dimmer and dimmer and dimmer because the sun's there and it doesn't have to, you know, be by itself in the dark. Okay, what are you showing us now, Cami?
Okay, now I know people, as far as I'm saying, I can see through the moon and I can see through different things. And this still with the visual and the moon being a rock, it doesn't work with a lot of the things we observe in the sky. And listening to, we're going to do this, like reading through all of the different things in that and reading about the heavens. It was interesting. I kept on seeing the firmament being described as a vault of looking glass or a shiny river or all of the just different things that had very, very glossy mirror-like things. I also had in my possession a toy called a mirroscope, which is simply two parabolic dishes filled with mirrors on the inside. But if you cut a hole in the top of one, what you get is it uses parabolic action. It makes a focal point, and it takes whatever in the dish, creates a focal point, and not only does it create a 3D, I don't know if you want to call it illusion of it, but this 3D image of it also carries with it other functions other than optics, meaning that like usually when we think of a hologram or something as a strict illusion is a strictly optical, only messing with our eyes. This, because we're using a parabolic dish and we're putting something in it. If you put something hot in it, it's going to focal point the heat. If you put something cold in it, it's going to focal point. In other words, it's going to make a focal point of a lot of our wave functions. I think, you know, most of our wave functions in it. We use it for radio waves. Look at the technology we use parabolic dishes for and what we do with it, sending signals and that. So this is just using parabolic function to create a focal point. And I thought, isn't that convenient that the way the firmament is described?
Okay, hold on one sec before you get away from that too far. People are asking mirror dish. So do you have a mirroscope close to you? Think of a flying saucer, folks, and that's all it is. It looks like, you know, two saucers stuck together almost, and they're hollow. And on the inside, they're mirrored. And one has a hole cut out through the center. And that's all it is. Now, the angle has to be a certain angle, doesn't it?
Now, the angle does not, they're parabolic dishes. So that's what I mean. This is what I'm talking about when I put out things with variables. Depending on the angle, it moves the focal point in a different place. So in other words, I don't know. What it does is it just opens up a lot of possibilities.
Yeah, they always come with the same angle, don't they?
No, they don't come with a different angle. Different manufacturers come with different angles. It's not a magic angle, Zach. It's a focal point. Depending on the angle of it, it will create the focal point in a different place.
Well, yeah, but so it's if you have, always right at the top there, at the center of the hole.
Well, these ones, they're making it there, but I've had some that are sitting a little bit higher and a little bit lower and down in it. So
I've never seen anything like that. All of them I've seen that you've had were all the same look and the same shape.
Well, that's because it's meant to create that exact illusion. But again, you can move your focal point by changing the angles of the mirror. You can still create a focal point. You can create, again, I've had different ones that are slightly different. So they're variables on it through the different manufacturers. If you remember, the larger one we had a little bit of a steeper angle to it. But it just puts it, again, it's like where it puts it is the illusion is where it drops it down is the main thing on it. Now this, so the mirroscope, if you put the phases, what I did here is I played with well, let me play. StreamYard is sharing your screen. Stop sharing. No. There we go. This, what I did is we're just looking at, I'm playing with something in a miroscope, and I'm creating the phases by moving up and down by comparison. And again, it's sloppy in a miroscope, but you'll see, do you know how the terminator line on the moon is so fuzzy and such? And doing it, people say that there's no hot spot on the moon and it doesn't look like a reflection. And I have to agree 1,000%. It does not look like a reflection, but when you're exciting with UV, you're not reflecting it. You're actually causing a chemical reaction in the material itself to excite by the exposure of it, and it causes it to give its own light and fluoresce and glow. So it's not a reflection, it's an actual light creation. It's a creating fluorescent light. So I think the moon is creating fluorescent light, but I also think it's happening a layer up from where we see it. And I don't know if the way that we've looked at heaven and that, if that, or the way that in everything has described the firmament, they describe the heavens above us as the first heaven is where the birds, and by the way, I can take this out of Christianity and put it into every single mythology too. I will do it in Christianity right now, but I can do it into Celtic and every different one. This is systematic. This is not built with a specific religion in mind. It's very systematic. But where they put the first heaven is where the birds are and where the birds and that fly. And your second heaven is the firmament, and the firmament is where the sun and moon are and the wandering stars. They don't say about the other stars. They talk about the wandering stars and the sun and the moon in the firmament. And then your third heaven is the high heaven, the holy of the holies. So if you
I had to mention here that some birds are known to fly up to 37,000 feet up into the sky. So we've got some really high flying, and that's just as far as we know of. The highest flying bird that we know of flies up to 37,000 feet, which
Who
I
flies
think
that
is pretty
high?
incredible.
Which
Huh?
bird? What birds do that?
It's a vulture. It's the Ruppel's vulture.
Really? I was
What
I
was
would
it
have
called?
guessed like
Vulture.
maybe condor too or something.
Yeah,
Or
there's a
albatross.
couple birds that can fly
Or
like
albatross,
really
yeah.
high up there. Yeah, and with that, I start thinking about that, and I hear about the windows of heaven and about birds flying into the firmament. I was like, I wonder if some birds are actually able to reach that high. That we just, because we don't really have a way of monitoring exactly how high every single bird can fly yet. But yeah, there's so much out there. But yeah, that's how as high as we've seen them.
That would suck. Hitting one of those in one of those big planes.
Yeah.
Whoops. I wonder if that's
35,000 feet up, you run into a bird.
Jeez, that would be crazy.
37,000 feet up. Yeah.
Now, I saw you were showing some stuff there, Cami. Were you
so you
going to
want
go into?
I was going to go into the miroscope, and I wondered if, or also on the world, I was just wondering if it would be easier to do that, but we would almost, so on the sky, again, that's what I mean. I don't want to cause arguments as far as, no, it's not solid or it's not in the sky. I have moved it up a layer and made it that what we're seeing is is the focal points of what's happening a layer up, if that makes sense to people. So in the model, when I'm talking about the moon actually being what I think a rock, and the reason I think it is a rock, and everybody thinks it's so crazy to have a rock, I don't think it's a crazy idea, because nature builds it builds in vegetable, mineral, or animal, and those are the phases of life. It looks like a giant rock to me. It has all, as a gemologist, I've gone in and seen things that look like different inclusions in that. Well, we've actually taken our P900 and our telescope and have zoomed in on the moon ourselves personally, and we've gone into it. I can't believe how much zooming in the moon is like working under a microscope, which I did for years. The telltale signs, they are there, and to me, it makes perfect sense that it would be not something made with wire. I mean, we grow rocks, and you would grow a light to with the characteristics to make what you want. I have things on my desk that glow like crazy. Again, with a little bit of this is just long wave, but I don't know if you can see how crazy that's glowing. Does that pick up at all,
Not
Zach?
the greatest. What about your other
Yeah.
camera?
Oh, on the other camera. Yeah, you
I
know what?
bet
That's
that
not.
would work a lot better, and I can pin that one up there.
Let's see if I can. I'm going to have to. You're going to have to stop sharing a minute to do that because I have to switch cameras, and it's not so easy. It's on a different. I have to change my settings here. It was underneath
Okay.
it. There we go. Watch
Now, what
this.
kind of rock is this? Is this the Uperlite?
No, this one is one I can't pronounce. I have the Uperlite and the other, and I'm not even going to try to. It's a rare variety, but again, I loved it for the fluorescence.
The Uperlite is the one, the famous one around Lake Michigan. Is that right?
Mm-hmm.
You got one of those? That's
That was
crazy.
discovered
course I
in
do.
2017, I think.
And it
And
was
you've got
all
one. That's
along.
awesome.
Of course I do. There we go. So I'm doing this just so when I move things, they move with me. Otherwise, you see what I do, I get all confused. Yeah, and I'll go get the Uperlite. I know exactly where it is. It's a few footsteps away.
Wow.
That's cool.
I can see that.
And that is itself taking off too. I mean, it's just taking it glows to this. We'll put a little piece of Uperlite under here. In the meantime, we'll give you some eye candy.
A little bit of eye candy,
A little
magnetic
bit of eye candy. A little bit of eye candy.
flux.
Magnetic flux lines.
Yeah, that makes me wonder how many rocks have I walked on that have never been categorized yet?
Yeah.
I've walked on the Upper Peninsula shorelines up there a
His
lot.
crew who's tested all the
Probably
things
walked
at
by
the
a whole bunch
different.
of Uperlites.
Yeah, I could have walked on a bunch of them. I would have had no idea. They found them by accident because they were looking for a different type of rock, actually, that fluoresced when you shine this certain light on it.
Mm-hmm.
And then they're out there looking, and sure enough, they were seeing other things that are fluorescent. Like, whoa, what's this? 2017. That's crazy. Look at that. Imagine coming up on something like that at the beach.
So this again, it produces cold lighting. It's producing light by itself, and the fluorescence I have, like with the thing, creative fluorescence, bright enough that it's casted shadows. So again, I was doing different things because that was some of the different things I was testing. Can it get bright enough to cast shadows? We get moon shadows. Can it do this? I was getting yes on all of these hits. So I kept going, testing with reality. But when I'm saying like the different things I'm doing, I'm touching and testing and saying, does this work in reality? So we're going to get to the next. We'll keep on going. That leads us in well. Okay, so I'm going, oops, sorry.
Yeah, that is beautiful.
Anything else people want to see under the, no, we'll do that later, but do.
Mr. One-to-One is saying something about Safari. We don't stream on Safari. I'm not sure what you mean by Safari. Is that another streaming platform?
Safari is,
Or is
isn't
that a
Safari Apple?
web server, maybe? I don't know.
Web browser, yeah.
Web browser?
So,
He's saying he's over there on Safari, and there was only a few people in the chat on the Safari browser.
Weird.
Yeah.
maybe he's talking about on our chat. We have, well,
Don't
It needs
you?
yeah, I'm not sure.
I can't see. I think it's 147, but I'm not sure. It could be 47. Hard to see. These eyes are need the
Sorry
glasses on.
for distracting you there. I just saw that and I was like, what?
All right. Okay, I'm going to present again.
All right. Let me know when
Hold
you're
on.
ready.
Nope. See, this is hard, Zach, because I want to present the screen that you're on, and it's going to show my StreamYard. So, hold on.
I'll wait till you're ready. Yeah. Big shout out to Daryl Davis.
Okay. Yeah. Wait till I'm ready.
Cami.
Hi, Daryl. Yeah.
And I think somebody gifted memberships earlier too.
Yes, let me see.
Justin Johnson gifted 5 GLOBEBUSTERS memberships. Texas Tabla gave a $2 super chat. Shout out to you guys. Thanks for your support.
Thank you so much.
On YouTube.
Much, much appreciated.
And I am
Every
going
little
to
bit helps. You were going to share?
I am going to yeah. I'm going to share. I'm going to ask questions or do things. They're a little bit which one? You know what? I almost want a 5-minute break. Do we need a song? Do we mind a break for a minute, or
do you need
that rude? Okay. I'll keep going. Okay, fine. Fine. Okay, put me up.
Okay.
Okay, am I up?
You are up.
Okay. Next, okay, on the ground map, we're looking at, because it will tie into some other things with it, with the layers on it. We're looking at the magnetics. This is a declination map. And one of the very first things we did early on was Karen B, Diva, People Got Pieces, and Karen B and Palatnet was able to put together, and this was in 3 different pieces. Now it's easy to do, but she put together this beautiful, again, taking our declination and being able to look at it like this. Now this was something spectacular to me because I'd been looking at our declination maps for a long time, and I was seeing things in it. And I have a very good way of putting visuals together, but this was stunning on how it came together. I was even surprised because, again, this piece here that was off of my maps, Pilot had. My map started after the insert of it, so I saw the waves going and doing this. But what we had was a map that in the globe Earth made no sense at all. All of a sudden in flat Earth, when you did it, I looked at it, and this is a very, very coherent magnetic pattern, not just it's a brilliant magnetic pattern on here. This is called a quadrupole, and a quadrupole on here will create, by the way, a perfect toroid when I'm doing this. When you guys saw the clover leaves on that magnetic film going through, that was a quadrupole underneath it, and you saw with the magnets doing it, for creating your leaves. Your quadrupole is what they use at CERN and what they use and most of the equipment. It's a brilliant way to do the same with Helmholtz was, and that is your brilliant configuration to do this. And this is in electromagnetics as well as magnetics itself. I know that Space Audits was talking it, and they were saying it's not a magnetic, it's an electromagnetic. And I will agree 100%, but your electromagnetics also create some of the same patterns. This, again, configuration of the Helmholtz. The reason this is so smart on your toroid field is this is a field stabilizer, a field extender, a field, everything about it. It extends it out, it makes it stronger, it stabilizes. It's instead of a single magnet doing it, it puts it together and it makes the perfect, again, your perfect quadrupole thing. And this is our declination map. This is what we fly by. It's right there. Your next piece, you have a pole here. This is, they were talking about where I'm taking it into because I'm thinking about watching Space Addict Alan last night, where the ferrous material would accumulate, and we don't see that. We actually do. We see it accumulating here. He was saying that wouldn't happen. It happens both in electromagnetic and a magnetic. Again, you can swap the two out. But you have a pole here. We found on the quadrupole doing it that there's another learning through here that, again, we have tried that if you, people are saying we have nothing in the middle, that we show a vortex and we don't show a huge. So some people say there's a land that's, again, very, very well unknown. But what we have is we have an incomplete pattern. And this was very exciting. You have this, you have this, you have the red and the blue going. And where the red and the blue go here, they don't know how to do anything but in reality to come together. They know nothing. In other words, they can only come together. It's in nature, in reality, they're the two sides of the same
Pressure
coin.
mediation.
It's pressure mediation. They only know how to come together. They don't know how to do anything else. We could break a wire again and do a thing on it, but again, your red and your blue are going to come together. It's the only thing they know how to do. So what I did was I took this. So that means we have red and blue out here, which to me means we have more land. We have more land off of the map that would need to, again, be what we have Australia, our big piece of Antarctica here. We need another piece there. So I went ahead and I put it in just because it's needed on our turtle map for that. And what happened is as I looked at the magnetics again and was watching Ken Wheeler, and one of the things he came across was your quadrupole. God, it caught me. It blew me. A way to make a quadrupole, a new way that he just learned to make a quadrupole is if you take two dipoles, this is a dipole, a quadrupole will create itself in the center. So we put your two pillars in and your stairway of heaven creates. To me, that was just, again, different hits on the pattern did it itself. As soon as I put the other dipole in, it didn't know what to do but to make that quadrupole in the middle. We go back to the turtle map. Is it put in the magnetics, the plus and the minus on our magnetics, or that. We also talked about, again, where it comes out, if you were going to establish the Earth, what would you do if you were going to stabilize this magnetic pattern? Because this magnetic pattern, the other thing is when you extend out from it, it pops out a shape all by itself. A quadrupole and, a quadrupole, again, created a shape that, again, if you pull out, it creates, Zach, you saw it on there, it creates a shape all by itself. It builds its own outline. This is the shape going around it. So again, I'm just drawing in these fields that I'm seeing. And then I'm taking as we have heavens above and heavens below, what would happen if we replicated our four corners, your things that were built by the pillars, and build it up. And what I came up with, these are magnets here, by the way. They're magnetics on the patterns, and I'm building it up. And I...
So kind of explain it how it's 3D,
How's that? How's that? So it's in 3D with your stairway up the middle. So if I started looking at it, and when I put it in 3D, what it looks like I have a sephiroth. It really does if I do the different layers on it. And so I was looking at the layers. I couldn't help but not see that when building it up. And then take the layers you had, our layer that we live on with our birds and that, your heaven, that I have a better one of this too. I have one that was further along. It's so funny, I pulled the wrong one. But you have, again, your dark sun or your Rahu and K2 that are filtering through the magnetics, if you'll see, and making your magnetics, by the way, if your magnetic is running here, and here, optically, you're going to get a circle going around here, but you're also going to optically circle what's in the sky here and here around their magnetic poles. So I think that might be the answer to southern star rotations, that it's an optical picking up because of the magnetics are a possibility. And again, I have played with optics, with magnetics, with crystals a lot visually, and the things that you can get them to do. The easiest thing in flat Earth to do was to get the optics to jump, like getting the sun and moon to appear anywhere I want, or doing things with optics. The hard part is getting the properties to go with the optics, because we know when we see the sun, we feel the heat. It's more than seeing; it's a feeling. We measure the UV, we get burned, and so it's also getting the different properties. And yet, people say, oh, "I can see through the moon." All of this stuff makes sense to me, but if you look at the model and just started laying it in, and again, that's an old one that wasn't very far. I have different editions of these things.
There's a question in chat real quick. He was asking about the green lines on the magnetic declination map. So those lines, when you don't, like if you take a magnetic reading from there, that will point to north. You don't have to change it at all. You don't have to adjust it. All those other lines, it'll tell you, like when you get real close to the poles and the circle's real small up there, that's 90 degrees off of where north would be, it's telling you. So really, when you're pointing this way, north is actually straight ahead of you. Most places aren't off. Like here in the United States, they're not off that much when you look at the map. Here, I can bring it back up real quick. Cam, you don't just stay where you're at. Yeah.
Okay.
See, like here in the United States, the green line is running right through the middle of the United States. And then each line is, I forget how many degrees.
It's like 5 or 10 or something like that.
Are they, yeah, the big lines, right? Yeah, these big lines, there's 10 degrees off. So from here, you would be 10 degrees off when you're measuring. And that's like
the green
up
line
near New York.
That
would be 0. So when you're taking a magnetic reading along this line, you don't have to account for declination. You don't have to say, well, because of the because usually your magnet doesn't point directly north. It's
your even pressure. It's your area of a gunner that it shows 0 again pressure, and it's where your compass will point true. Again, it doesn't deal with the pressure mediation on it. While you're talking about that and the lines on it, I'm going to bring up this little map that people talk about, and I want people to stop and look at it critically, because my my idea of what am I presenting or no, I do not see.
Yes, you are presenting.
Okay, because this map here that we've seen, to me, what this has always been, and the first time I saw it and doing with the magnetics, and I want you guys to go ahead and run this with the magnetics, this to me was a map, an actual correct map that sailors use in the sea. And the reason I'm saying this and the way they write the east and the west and the equator and everything is you see this in how your compass reacts. These are notes. These are areas where you would switch your compass declining east to west. In other words, your natural switch off. So if you look at North America here, and you go to North America here, your line is here, you have your east, and you have your west magnetics in the sea. You follow it along to Asia, and your equator. These are, again, your compass. They're giving you your east to west thing and west to east. They're giving you exactly how you would read your magnetic lines, just on, it's telling you nothing but like where you are and what way you need to adjust your compass.
Is that what the gray line is going all the way across it?
This gray line here?
There's a big gray line going all the way across the.
Yeah, that gray line there is what this line here would be here. Do you see my screen here?
Yeah. Well, I just learned something today.
That goes through.
And this is again,
right there.
Yep. It sure does. Greenland, and you see where Greenland is right here to this side, and Europe to the other side. These are things, and again, these are Cami's theories, but I look at it and it looks pretty darn, it looks pretty darn good to me. You have Greenland, and again, you're east. Now you're going to switch over to west again in Europe right here. Here you're going to switch over. Now you're going to switch over to east. This is just again, your longitude, your latitude, and it's telling you, again, look at how clean against the lines. I see that, and it's like you're just talking about how on your, if you had a declination map or that, you're just telling yourself how to interpret west or east. You turn your cup, which way do you want to adjust for it? And it is a mark-off line. So to me, this is a new correct map of the flat Earth surface that he did back there. And you're like, whoa, there's no map there. I think it's correct. I think it's correct. I don't think there needed to be a map there. He reads the compass, reads north here, and here's Africa, here's the land. We have land maps. We have land maps. He's just saying
this is the John G. Abizade map.
Yeah, this is we have the land map. This is saying what your compass does. It jumps here, here, there, and there, and that when you're mapping and doing things, this is where you cross over and do it differently. Is again, and it's in all of the old, I think people knew about it. This is a old magnetic map that Karen's, again, did her magic on. You'll see our equator. You have your magnetic equator. You have your regular equator and your magnetic equator, and you'll see that you have so when I'm talking about an ellipse, and my ellipse, by the way, our egg shape works perfectly. If you think about where our magnetics are. Again, go back to your map and think about where Australia is. And that strong, you can see it right here coming.
Mm-hmm.
I think this is a great map, by the way, on it. Strong coming your equator. So if you had your strong pole, that's where you get your widest point here on your egg, Karen. And then again, where this pole is further out, the one that's off of the map, that's where we're getting our tip of our egg. We did that years ago, and after you found the thing and did it, it pointed to the same place. I said, I think there's land there. Where the egg points is where I think there's land. And again, why do I think there's land? Because I think like Antarctica, we need a big piece of land to establish it. Again, I think it builds our patterns. So this was something, and again, all of my art is great. Karen, you'll notice it's all done in office clip art because at the time, including the other one, because that is what growing up in an office had no. It's like, okay, these are little clip arts. I can do that. I had this in a workable one-on-one of it, but this is just an idea of it's much better when it's workable. Your magnetics and laying it over shows again your layout. It shows your rotations, your stars. This is taking in your firmament, which puts that the heliospheric current shapes and all of the stuff that I'm working on that makes things fluoresce glow, stuff that we know are really there in the heaven of the heavens. But this is old stuff via, I think, 2017, Zach. When did we do some of that stuff for Iron Realm even?
Yeah, 2018, I would
2018,
say. 2018.
Yeah, I think
I'd been because I had met you in Denver at the conference.
And I'd been working on it for a while, so like just putting it in different things.
Yeah, you had been working on it for quite a while.
And just even like the firmament, vault of heavens, vault of mirror glass. You're going to do this again. We're going to the stars, this idea, sidereal time, and that this is adding in a JC's thing with the stars about it. But I almost think that the way that we're breaking it up here, your ionosphere,
would make that different. Yeah.
So again, it's always going to be right now.
your magnetics and again your ley lines, and this is early on going back. I have really bad scribbling notes too if I pulled back on the things. But the thing about putting together these is there's nothing in here. In other words, the pieces I'm using really aren't of my own. I'm connecting dots. And trying to filter out stuff that's not real. And so I want to, like, again, have feedback on things, especially like things that don't work. I mean, things that don't work. This, again, I built in with the quadruple and the different things and getting fancy, but really interested in you learn from the anomalies, you learn from what's different and what doesn't work.
Mm-hmm.
And with that, you know what? Now I get to take a break a minute. We can take play a song or somebody else can talk because I have to go have a drink.
Okay. Well, that might just do it for this evening's show. Unless Cami had somewhere else she really wanted to go. Did you guys have anything you wanted to add there about any ideas?
Yeah, well, I just want to say that I've been privy to looking at Cami's stuff for a while now, and the more I look at it and the more I look at it and compare it to how things work in the real world, the properties of different materials and how you can manipulate them with temperature and all that stuff, it really sort of gives me the clues and the ability to sort of picture it all working in my mind, and it really also backs up all the stuff that I've been learning about crystals, also due to Cami, and it's kind of a trip too, because if you look at the shape of that Kabbalah, it looks like the shape of a crystal like lattice system. It makes sense that something like that would be part of the larger part of the structure of the physical world that we live in. I mean, it even talks about the pillars in scripture, right? And the pillars are those crystalline pillars. What type of crystal are they made exactly of? I don't know, all types, mostly quartz, because quartz is the most plentiful, I'm guessing. Lots of salt. There's just all types of different things, and these minerals in these large quantities have immense power inside of them, enough that would seem to me to cause a lot of the things that we know that happen, like magma chambers underground, because there is piezoelectricity in these large amounts of crystals, and who knows, who knows? Like there's just a lot of things there that if we continue to look at it how they work, I think we could figure out a lot, or get close to figuring out to how this place really works, what makes it tick, so to speak.
Oh, how do I? Oh, I can't do that. Okay. Yeah, absolutely. Yeah, the more I've got to look into Cami stuff. Like at first, I didn't see a lot of the stuff she was saying until we got the toys, and actually I got to see it with my own eyes, and then I was like, oh, okay. Then it made sense to me. But somehow she knew it was going to make sense without those visuals.
Well, just because she had worked with that stuff,
Yeah,
that's what
yeah.
she did,
Mm-hmm.
was look at
It's correct.
the properties of these things, and
I
that's how
tested
she
properties.
identified. Yeah.
I tested properties in this. Karen, you want to see some of our newest toys with these things, or
Sure.
these? Sorry, this is just fun. But I left on one of our sheets. What I have is I have two Polaroid filters in my hand, and they're just embedded on glass, right? But on one of them, I left the cellophane over the top, so I have a quarter polarization added to one. But watch this. All I'm doing is I'm stacking them differently. So again, when we talk about the sun turning red and things during the eclipse or fading in and out, polarized light, we know it's up there. We know it has to be up there. It doesn't know how not to be up there. But the things the way you see things and it makes you see things. This is all, both of these these are just little polarized films. One of them has got another there on it, but you'll see there's nothing colored in my hand, nothing, anything. But how you see? I'm looking at the screen, and so this is Faraday effect, by the way. And again, these things are happening. Again, light is getting polarized. Isn't that interesting how just changing the position of it top to bottom when working with the quarter polarization to that's something to work into the red. I'm showing her this because like when we talk about things and I'm looking at models, everything I look at and doing it has to hit we know that like during a lunar eclipse, the moon like fades out, then gets red in the middle and then goes dark out again. I'm finding that if I put like things in phase again and are adding in where your sun would do it, I think your North Pole, I'm not sure if that's your quarter polarization or the full, but again, putting things into alignment, you get these color changes and you do that by aligning things differently. Just an interesting fact. Again, where it phases and it gets the angles, but we're touching things on the models. We just, again, mostly try to work with things that you can, or things that are real. Again, polarized light. We know it's their ultraviolet. We know it's their fluorescence. Again, things in nature, because to me, if it's part of the creation, I look and I see what the creator does. He does so much more brilliant than anything we could even possibly conceive. I'm not going to try to create anything to work with. I'm only going to look to the creator and use. That's to me, the whole key to this is not trying to build anything myself, but building or like observing what's there from the creator, what is already there that we're just missing. And that's the beauty of it. That's the beauty of all of these things is like none of this stuff is, it's all there. It's all already out there.
No fantasy stories needed.
No fantasy stories needed.
That was awesome. So is there anything else you would like to throw out there, Cami?
It's coming back. Hi. I don't know. I missed chat or anything. Did I bore people to death? Did I answer any questions? I was just trying to revisit, and we covered a lot and a little in a short time, but it was just, I talk about like the model and things, and I realized that some of these people I've never given, they don't really know what I'm talking about, or, I mean, they're not familiar with like the all over view of how I'm looking at things.
We all have our own way of systematizing the knowledge that we have, and trying to give people a tour of our scattered brains can be kind of difficult at times.
About impossible for this girl. If you guys want another, on my channel, there's something called Even the Rocks Cry Out that takes it further, and then we can dial in on these things. Thank you for the things coming across the screen. Living the worlds of encouragement. I am boring sometimes, though I really am boring. Interacting with, trying to get inspired and things like that. Again, it was listening to Pro Talk. Again, looking out my window, which I'm doing right now. It's exciting. I pray to my husband and say, push me along, because sometimes I just want to crawl on it. So it's like, Bob, give your wife a kick and say, no, we didn't do all of this for nothing. And I know that's what he wants. I know that's what he wants for me. So thank you guys for putting up with listening Because even though I'm not as good as my husband wanted me to be with presenting or doing things, I know that this is what he wanted. So we're getting there. And with this,
Absolutely.
and I feel that I'm such a bad presenter that it only gives me one direction to go in, and that's up.
You're not a bad presenter.
You're definitely getting more and more comfortable as you go.
Yeah. Yeah.
I started being petrified of having I started with flat Earth. You can see me running across the thing. I was scared to have my picture taken. Even. I did not like to have a snapshot taken of me. I was a scared rabbit on any picture, let alone being live on a screen. So overcoming like the battles of being totally scared of cameras was a big part of it. So we're getting there. I'm just much better in laboratory and my little nerdy type of things. But thank you, nerds that like to follow along with it. And any other questions? Or I love questions. I love hard questions. And I've deep dived a lot into a lot of these areas, even more. Pull up a million things, and I won't. Again, where the tides and the things do it. We didn't bring in any of the mysticism or the different things on it. But yeah, it all points to reality.
Maria Walker says, "Oh my gosh, I got to see that. I'm so into rocks right now. Rocks are where it's at, man.
Yeah.
The rocks, they don't make any noise, but they got all kinds of stuff to tell you. It's crazy.
They cry out. They cry out.
It's
They're talking to me
crazy.
today. Mm-hmm.
Yeah, she asked a question.
They're the oldest living things on this plane is the minerals. They're immortal. They are immortal. They break down and then they build back up again. They are part of the foundation of everything. You know, it's just
They're inside of us.
Yeah.
We're made of crystals.
Yes, our skeleton is crystalline. You know, that qualifies. There's just so much. We have, when our cells get together, when we create life, there's a piezoelectric reaction, there's a flash of light, there's just so much to it. And nobody's looking at it. Everybody's looking at other stuff and making up these crazy stories. Whatever.
I think there's a little bit of magic in there too. When the sperm meets the egg, can't recreate that. There's nothing we can do that can even come close.
I mean,
to the
that's why they
miracle.
call it the divine spark. It's the spark of life.
The miracle of life. It's so awesome.
It's beautiful. I know that when I talk about the dance of the sun and the moon, and that's something that's like your man and women and creating a child, that's one of the things the way I think of Moonlight is a descent reflection is the sun's. No, it's neither, because neither one of them can do it in its own. It's like a child. It receives from the moon receives from the sun, takes it, chemically processes it, and now it gives off its own light. It produces it. It dances with it. It could not. It needs both to create the light. I mean, it needs both things to do it, and it's its own light. It's not the same light. It's not a reflection. It's not the same as the sun. It's a cold light. It's a different light. It's a completely different, unique light.
Mm-hmm.
And the idea that it's a reflection when it's fluorescent light is just completely absurd. I mean, now I wonder if they backtracked over the last 4 years and saying that it's doing fluorescent in that too. But again, it's such a joke.
I did find an article at one time where it was like hidden, and it was like NASA was saying that the moon was photoluminescent.
It is.
And I was like, dude, boom, right there, right? That's
boom.
it.
They won't say that though. No, it's just
I don't know where it is though. I can't find it again.
They did that after we came out with it though, but it only makes sense. It only makes sense.
Mm-hmm.
It would have made. They should have grabbed it for their model ahead of time because it would have made their model make more sense. Maybe not during the eclipse. They should have grabbed it. Yeah, the reflection one is retarded. It really, truly is. Just ask Bob and the inverse square law. my husband has done some great past speeches on that. Well, Zach, this has been great. I came in and I haven't shut up the whole time. It's been a great show.
Well, yeah, you were going over your model.
I enjoyed that little refresher. It made me want to make new graphics for it.
I want new I want more graphics, and I want.
It made me think about. I'm like, oh, how could we make some cool little visuals for this to show? Yeah, we got to play with that.
No. I didn't. We were doing this before the show, and the lighting is so bad, we can't see it now. But if you remember our things about polarity, and we said we needed to make a whale with the bees, and looking at this guy, we did. And mine is even fancier, Karen. I have for optics and doing dishes, I used microscope slides that have a concave dip in them, and so you'll actually get breaks in the optics top and bottom. So we can do different things on the same wheel. I mean, they obviously do the polarity, but we can also, you can see where it does the concave and some optical things with it too. Just to give it, again, more bang for the buck. It does both. I like,
That's awesome.
Mm-hmm. It's the little things. In other words, we don't have to look through that little hole there. We can look anywhere we want. And those bubbly films on it, you see the bubbles? Those are, I have a cellophane film over the top that you're picking up. So those won't be there. But, and you can see that when it's off, this is what it looks like. That is funny when you do it.
Don't push those. Use the crank I gave you. They're not glued on there yet. Yeah. I don't want you knocking them off and breaking them.
So
I broke a couple of those things.
Tinker Toys.
Yeah, yes. Buddy.
We were sitting here and saying, we did the slides. It's like, what do I do to assemble? It's like, the only thing I can think of is Tinker Toys. And Zach is like, well, we have Tinker Toys. So yeah, these were what I was playing with before. It's just these little things. So on my desk, all the toys.
Yeah, I want to get more different types of optical crystals too.
Mm-hmm. This is, I have.
I need to get some different types of calcite and some other things. There's some other things you could do some real cool effects with.
This is the one that you look through and it circles it also on television.
Yeah, I got
selenite, depending on how you polish it, you can do so many different things. If you set the selenite here, let's do this one for you. Let's do one selenite for you.
Maria's asking about it's not a polarized filter, Maria. It's a hydrogen alpha double stack hydrogen alpha filter.
It's big, fancy, expensive.
Yeah, thing. They're quite pricey.
You could buy
the cheapest one I saw for my camera, which was a P610, which is only about that. It's not huge, and it was $610, and that was 5 years ago or whatever, 6 years ago, quite some time ago. No, I wish it was that easy. Just using Polaroid filter to see it. That'd be awesome.
Oh boy, would that be my dream? Yeah. You're not getting the hard with the this one. What it does here, and that you're having a hard time doing it. I'm going to need Karen's photography. Is it's taking the letters on there and it's actually moving them so they feel a lot closer to me. It's moving them it's moving them to the top of the stone.
Mm-hmm.
And she's
we don't really pick all that up that great.
Because I've got this set. Yeah, I need better photography.
Maybe if it was at a different angle, because since we're looking straight down at it.
Yeah, I think exactly that's what it is. We should be looking at more of an angle. But
that's exactly what it is. I don't know if I can do the, set it up for right now. With her things, we will set up the different things. But the other thing is if you hold one of these up to your eye and look through it at here. You actually look through this and look at anything lighter, that is going to take everything you look at and circle it around the center. It doesn't have to be circled before, but it will circle it afterwards or align and do it. Again, different things do. Magnetics also love to do circling, and they love to bend light. So just different things that happen, and to always keep in mind is with the optics, they can mess with you.
Mm-hmm. Ain't that the truth?
Ain't that the
So
truth?
much of this stuff we see happening in the sky, you can recreate with through the minerals and crystals here on the ground. You can create the same phenomena.
Yeah.
Yep.
We can create the phases, the different things. We can do this. Is it right? I'm not up there. I'm not looking, but it almost seems too easy in a way. But there are other areas. I wouldn't say that either. Keeps the mind busy. Certainly, for being too easy, you say if it's too easy, why aren't you done? And I'm nowhere near done. So, not too easy.
All right.
Well, I gotta get heading out here, so I have to leave early. But
Okay, no, that's okay. We're just about gonna wrap it up here. Yeah, I gotta get going too. I gotta be up for 5 a.m. show.
Okay.
Oy muy.
Well, thank you so much for sharing your model with us, Cami. Loved hearing about it, and yeah, look forward to learning more with you. So, peace.
Peace.
Right,
Thank you for
Kyle.
joining.
We'll see you next week, Kyle.
I'll see you next week.
And next week we're gonna be joined by Space Audits. Alan from Space Audits is gonna come, and he has a presentation he wanted to share.
Cool.
Yeah, so strap in, get your thinking caps on. This guy is wicked smart. Just like he goes deep on his research and stuff like that. They have those ether cosmology roundtables.
Mm-hmm.
He
Is it
and Sean and all
Toby
those
and
guys, Toby, and yeah,
I'd like
they're
to talk with Toby. I think is he the one
yeah,
into the magnetic?
he was saying that Toby might have a presentation he's interested to put on, and Sean's might have one that he's looking to put on too. So
Nice.
we'll pepper him in every couple weeks. Maybe we'll have
Love him in
somebody
there.
come
Sean
in
has
and-
some good videos about the sky.
yeah, and they've done some awesome research, and they get into the technicals about it too.
Sean or Shane?
Shane.
I think it's Shane.
Shane, sorry. Yeah, Shane St. Pierre. Yeah.
I'm thinking, who's Sean? Shane.
Yeah, I had a brain fart. Yeah, no, just awesome research they're doing over there.
Mm-hmm.
Space audits, ether cosmology, roundtable.
Keeping it real.
Yeah.
Yes.
So, Karen, have anything coming up? Anything new or exciting? Instead of you just having, I know, solar script sorry, anti-religious scripture studies.
Yes.
We'll be having one this Saturday.
Yes. And I've gotten back to editing the rest of the Flattoberfest videos from last year, and which I never did finish, and I'm sorry about all that. But life happens. So I'm trying to catch up on all that stuff. And yeah, the regular stuff. I'll be around.
Awesome sauce. When is Mark's thing gonna be?
Oh yeah,
Tomorrow?
Mark, May 4th. I think it's
Saturday.
Saturday.
Awesome
Yeah.
sauce.
So
Yeah.
look for Mark on Jim Brewer's channel on Saturday.
Yeah. I can't wait. I'll be in the chat answering
Yeah.
questions and
Yeah, it's super cool.
Yeah, very cool. It's spreading and spreading and spreading. Do you hear about all the football players? That one guy saying like
I was saying
15%
on
of the
Strange
players.
World. You listen, you football players. You go. They must be watching some of our channels. You guys got to come talk to us.
Isn't it?
Please.
They're gonna pay you no matter
Just
what.
come talk to us. Nobody cares anymore. The world's flat. Everybody needs to put their big boy pants on and deal with it. So just come out. The more of you that do it, the better off we'll all be. Just come on.
Yep. Start showing those children, lead by example.
Yes.
We need you. You are the true alphas out there. Stand up and be an alpha. If you know the truth, say the truth. It's that easy.
Yes. Come on.
Do it.
Do it.
Do it. No, definitely. It is time. And you were right. It was a great point. We took the brunt. The brunt is taken.
Mm-hmm.
We were
But
called
now it's time.
so
It's
many
time
names.
now.
So many names for you
So
people.
many told to drink so much bleach.
Oh man. Good times. Good times.
We're all. All
But we're
right.
still here, you know.
Mm-hmm.
The names and the words they said to us, they didn't break us. We're still here.
Right. I'm still here.
Grew up in a time where we always had sticks and stones, you know.
Mm-hmm.
It was a different time. It had to happen right now when it happened, because another generation and they wouldn't have stuck with it. They would have been called names and they would have been like,
Right. A little
that's
bit
it.
later.
Yeah.
Never would have happened. It had
Never
to be
would have
Gen
happened.
Xers.
Yep.
Gen Xers and boomers. We got you.
All righty, everybody. So that'll be it for the show. Just kind of a recap of, a lot of the ideas and thoughts and trying to build a model that you don't get to see the picture of, It's like, here's some pieces. We're not going to show you the final product, and we're not going to tell you how the pieces go together either. And guess what? Some of those pieces might not even be a part of that model. Here you go.
Mm-hmm.
It's like, yeah, it's going to take us some time to figure all this stuff out. And
Exactly.
we're going to make mistakes. We're going to hit, there's going to be bumps in the road. It's just going to happen. But we're going
It
to
is
keep
true.
plugging away at it.
We will. And for anybody that wants to write in afterwards and say, so the lady thinks that there's a giant miroscope toy in the sky. No. The lady thinks there's something possibly with mirrored surfaces that creates the focal point that meets the descriptions of it.
Mm-hmm.
I work with Tinker Toys and things because my budget allows for it. And you know what? I found out you don't need to be rich to test reality. That's an illusion. You can get pretty far. You can't get all the way, but you can do pretty far with, little things with your eyes even alone, just by keeping your eyes open, looking at rocks.
And I wanted to make a really nice one for, presenting at Flytoberfest and stuff like that. And I was like, no, you know what? Children need to see it this way. Because a child can go home and get some strips and, cut them up, and maybe they've got some Tinker Toys laying around. I don't know if children still do that. They might have to go up in the attic to mom and dad's toys or whatever. But yeah, they can see that child's toys can be used to study this place still. You don't have to have, all the scientific gear and gizmos and gadgets. 90% of the stuff that I've, got stuff together with was stuff I find around the house. I'm a junkyard gardener, junkyard, mechanic, or whatever you want to call me.
Junkyard scientist?
Yeah.
That's awesome.
You don't have to have all the fancy stuff to get the results, or to learn something from it.
Mm-hmm.
So, all right, folks, that's going to do it. Oh, go ahead, Cami. Did you have something?
That was it. No, I was just going to say the key is to actually try to understand and not just learn the words. I think it's a key point to it. So I think that's it. I think have a great night. We keep on saying it's time to be over with. Let's be done. Good night, everybody.
9 o'clock. Good night.
Remember, be good to each other. Don't lie to each other. Open your mind because there's truth inside. Peace out.